This lesson is about zeros and multiplicity of polynomial functions. This is kind of a fun lesson. It's much simpler than the last lesson we did, and I hope you enjoy it. So we've already talked about zeros of functions. That is your solution for your function. So this is where it crosses the x-axis, and they can be called roots, zeros, solutions, x-intercepts. Those are all talking about just where the function crosses the x-axis at. So we've done that for a while. Today we're going to take a different look at it and kind of look at the converse of that. So we know that if the graph crosses the x-axis at negative a, kind of like it does here, that tells us that negative a is a root or a zero. Okay, so that is a solution. Now, we typically have been looking at these from factoring. So remember, we'd factor our polynomial and we would get something like x plus a as one of the factors, and we'd set that equal to 0. And then we knew that negative a was a solution. So this time we want to go backwards. We want to look at it the other direction. So if I know that the graph crosses at negative a, then I also know that x plus a is one of the factors of my polynomial without actually having to do the factoring. We can say the same thing about b here. If I know that b is a solution, then x minus b is a factor. Okay. And likewise, if c is a solution, then x minus c is also a factor. So remember, we have to change the sign because we had to move the term over to where the 0 was. So we either subtract from both sides or add from both sides. So basically, we're putting this constant back over with the x and setting it equal to 0, and that tells us that it's a factor. This is going to allow you to answer those questions on your homework where it gives you a graph and asks you to identify which polynomial function could represent that graph. The second thing we need to look at is multiplicity. And this sounds very complicated, but really all it's doing is when we factor, we're looking at how many times is a solution repeated. So we get these polynomials that we factor, and let's just say that we have x plus 1 squared times x minus 2. Okay. Multiplicity says we have to look at these exponents, and notice that if it's not written, it's a 1. And what that tells us about our graph is if the exponent is odd, then the graph is going to go through the point. Okay, so this solution right here is going to have an odd exponent. And we would write the simplest, so we would write it with an exponent of 1 if we were going to write an example. Same thing over here, this solution over here would also have an exponent of 1. So if this is, it is really hard to see, you guys. I'm so sorry that it's so small. This is -1 and +3. Okay, so that tells me that in my polynomial, if I have -1 as a solution, then x plus 1 is a factor. And if it goes through, it has to be odd. So I'm going to leave it as an exponent of 1. Okay, and then I also have a solution of 3. So I know x minus 3 is a factor. It also goes through, so it's going to keep an exponent of 1. Now, the other side of that is what if it's even? And if it's even, then it bounces at the graph. And so this example here where x equals 1 is an example of where it bounces. Now, it can also bounce from underneath. So it can bounce this direction. Okay, it doesn't have to be on top. But that means that this solution or this factor, of x minus 1 has to have an even exponent. So I would write that as a 2. Okay, and then I could just say that this was one sample of a function of f of x. And then you would square this, distribute through, and find your polynomial in standard form. Okay, so let's look at some examples of how to break this down and kind of see what is happening with our graph. So this polynomial is already factored for you, so it's easy to find the zeros of the graph. So if x plus 7 is a factor, I know the 0 is going to be -7. Remember, we're just taking these factors, setting them equal to 0. So subtract 7. Here, I'm going to have to subtract 1 and then divide by 2. And then this one, you're just going to add 4. So we have a -1/2 and we have a +4. Multiplicity is looking at the exponent. Okay, so this factor x plus 7 is squared, so it has a multiplicity of 2. The -1/2 factor has a multiplicity of 1, and the 4x minus 4 factor has a multiplicity of 3. Now remember, for the graph, we're just looking at if it's odd or even. If it's even, it's going to bounce at that location. And if it's odd, it's going to go through. Okay, so to kind of give us an idea, that was really crooked, sorry. In order to give us an idea of what we think this graph might look like, I'm going to go ahead and plot my zeros. So I have a 0 way over here at -7, and I have a 0 at -1/2, and I have a 0 at 4, okay? I know that if I have x squared times a 2x, okay, that's going to be x to the third, and then another x to the third is x to the sixth. So my leading coefficient is going to be x to the sixth. And it's also going to be, this is positive, and this is positive. So it's going to be a positive. So I know that it's going to go, let's see, at the 2, at -7, it's going to bounce. Let's see, if this is positive, it's going up and to the right. Let's back up. And then at this point, which is 4, it's going to go through, which means we're going to have a negative down here so that we can come back to this point, which is -1/2. It's going to go through here as well. And then it's going to have to bounce. So that means we're going to have to go back up again. And remember, my coefficient was even, so the right and left end behavior should both be in the positive direction. Okay, and you can graph that in Desmos if you would like to verify how that looks.